Hello everyone, this is Vijay Lakshmi Subnari. Here in this session, we have to discuss the concept multiple choice questions for second PUC mathematics. Here, my WinMaths channel is a free YouTube channel helping students across Karnataka to excel in their PUC board exams and competitive exam. This channel helps those who are studying PUC and your guide in making a PUC preparation. Here, we have to discuss the multiple questions now. First one chapter, relations and functions. First question, a relation R in a set A if each element of A is related to every element of A. For example, I have considered a one set. Okay, here I have considered a one set A. These containing elements 1, 2. Okay, then what is the relation? Relation is if each element of A is related to every element of A. It means there is a element 1. 1 is related to 1. And again, other than 1, there is element 2. 1 is related to 2. Similarly for 2. 2 is related to 1 and 2 is related to itself only. Okay, I can write it here. Every element is related with each element. Okay, now we have taken the result. Okay, based on the relation, we have to justify all the values. Here, first one, 1 is there, 2 is there. There are two elements, their images, okay, are present. Hence, reflexive property obeys. Similarly, I have considered the elements 2, 1, comma 2, 2, comma 1. Okay, 1 is related to 2, 2 is related to 1. Then, similarly, I will consider 2, 1. Here, for this one also, it obeys. 2 is related to 1, 1 is again related to 2. Okay, hence, this is symmetric property, obeys. Again, I will check the transitive property. First, 1 is related to 2, 2 is related to 1. By the property, again 1 is related to 1, this is present here. Transitive property is also obeys. All these properties are obeys, then we say the given relation is equivalence relation. Okay, this is the equivalence relation. The answer is option number D, equivalence relation. Then, both empty relation and universal relations are called as a trivial relation. Okay, empty relation and universal relations are called as a trivial relation. Then, question number 3. A relation R in the set 1, 2, 3 given by relation 1, 2, 2, 1. Okay, here which property or which relation here obeys? 1, 2, 2, 1. Okay. Here in this function, the symmetric property holds. Okay. The only thing is symmetric property holds. Here not symmetric, this is not neither symmetric, not symmetric and transitive. But here there is no transitive relation, so no, neglect it. The only option is the relation is symmetric but not transitive. The option number B is correct. Next, to move on the next question. Question number 4. A relation R in the set 1, 2, 3 given by relation R is equals to. Okay. Here there are three elements are there 1, 2, 3. So first have to check the image of these three elements. 1, 1 is present, 2, 2 present and 3, 3. Hence what we say reflexive property holds. Again, I will check. 1 is related to 2, 2 is related to 1. Okay, it obviously obeys. But 1, 3, 3, 1 not there. Okay, so this is not a symmetric property. Symmetric means each pair has their relation. Okay, each pair has holds the relation. Okay, next third one is this obeys reflexive property. Symmetric obeys only for 1, 2, 2, 1. But there is no relation for 1, 3. Hence, symmetric not there. Again, third property, transitivity. Okay, transitivity. Here I will check the transitive relation. Okay, first here 1 comma 2 is there, 2 comma 1. Again, related to third element, 1 comma 1. Okay, it is present here. Similarly, I will take 1 comma 3. 1 comma 3 and 3 is related to 3. Again, 1 is related to 3. This one is also wholes. 1 is related to 2. 2 is related to 2. Again, 1 comma 2 wholes. That's why transitive property is also holds for this one. Okay. Then I will check the options here. Reflexive and transitive. Okay. Option number A is correct. The relation holds the reflexive and transitive property, but not symmetric. The relation holds transitive, reflexive, but not symmetric. Then question number 5. A relation R in a set 1, 2, 3. Given that. Okay. Here mainly there are three elements. Have to check the reflexive property. Each element carries the images. Here there is a only one is there. One element has the image, but 2, 2, 3, 3 not there. That's why reflexive property not holds. Holds. Then here 1 comma 2 is there. 2 comma 1. Okay. 1 is related to 2. 2 is related to 1. Symmetric property holds. Again, for this one, transitivity. Okay, transitivity. 1 is related to 2. 2 is again related to 1. Again, by the property of transitivity, 1 is related to 1. It is present. Hence, the transitivity property is also holds. So, I will check the relation here. Transitive but not symmetric. This is not. Symmetric property also holds. Symmetric but not transitive. Symmetric and transitive also, but option is wrong. Symmetric and transitive. The option number C is correct. Now, question number 6. Let R be the relation in the set 1, 2, 3, 4. There are 4 elements. First have to check the images of their elements. Okay. There is a 1 image is there, 1, 1. Then 2, 2 is there, 3, 3 is there, and 4, 4. Hence, it holds the reflexive condition. Again, have to check the symmetry conditions now. Here 1 comma 2 present, then 2 comma 1 not present. Hence symmetric property not holds. Even for any pair, the property not holds, the whole property not holds. Okay. If even the property only holds for one pair, it is not obeys. Okay. Hence, again 1 comma 3 is there, 3 comma 1 not there. 3 comma 2 is there, 2 comma 3 not there. That's why symmetric property not holds. Similarly, I will check the transitive property. Okay, transitive property. 1 is related to 2. Again 2 is related to 2. 1 is related to, okay, transitive property holds. Again, here I will consider 1 comma 3. 1 is related to 3. Again 3 is related to 3. Then that's why what we written 1 is related to 3. Okay, this is the transitivity. Similarly, 3 comma 2 is this one is also holds. That is reflexive and transitive property holds. We will check the options here. R is reflexive and symmetric. Symmetric property not holds. So the option is not there. R is reflexive and transitive but not symmetric. Okay, this one is holds. Therefore, the option number B is correct. Next, question number 7. Let R be the relation in the set n given by. N means set of natural number. N means set of natural numbers. So, given by R. Here, the basic set is taken as a natural number and R is A comma B. There is a relation. The pair is A comma B. What is the value of A? A is always B minus 2. Again, here B is always greater than 6. Okay. B is greater than 6 means we have to consider here A value B value. We have to consider B is greater than 6 means the values of B are taken as a 7, 8, 9 up to so on. Okay. Here, what are the A values? Have to check in this equation. When taken B is 7. What is the value of A? 7 minus 2, that is 5. What is the pair? 5 comma 7, first pair. And for 8, what is the value of A? 8 minus 2, 6. 6 is related to 8. Okay. Here, I will check only these two because here 4, 8, 8, 7 are present in the pair of B. Here, this means A, B, A, B, A, B, A, B. Check the values. Here, 6 comma 8. Where is there? The option number 6 C is correct. 6 and 8 are belongs to the relation. This one relation holds the values. Then, question number 8. Consider the non-empty set consisting of children in a family and relation R defined as R is related to B. Okay. Children's in a family. In a family, children's may be. In a family, children's may be boy or girl. Okay. They are not given, taken as a boy, girl or not. Okay. If it may be boy, it may be girl or both are there. Okay. So A is brother of B. Okay. A is brother of B. A is not itself a brother. Okay. Here for the reflexive property, A is not itself as a brother. So reflexive property not holds. Similarly, I will check the symmetric property. A is brother of B. Okay. A is a boy and B is a girl. Okay. A is brother of B. But B is not a brother of A because B is again sister of A. So the property is not holds. If they have to mention both children are boy, then the condition will be satisfied. Otherwise, it fails. Okay. Hence, the symmetric property not holds. Again, I will take the transitive property. A is brother of B. Okay. Again, B is a girl. Again, I will consider a one boy. B is brother of C, not because she is a girl. Okay. She is a girl. She may be sister. She is sister of C. The property not holds. Therefore, the answer is neither symmetric nor transitive because in any one option there is no given for reflexive property. That's why neither symmetric nor transitive. The option number C is correct. Next, question number 9. If a relation R on the set 1, 2, 3 is given by, defined by relation 1, comma 2. Okay, here 1, comma 2. Even there is only one set is present, so there is no comparison of the relation. That's why none of these. The answer is none of these. Let N denotes the set of all straight lines in a plane. Let a relation R be defined by L is related to M. L is related to M if and only if the relation is if L is perpendicular to M. Okay, there are lines L, M, N. I will consider 3 lines. First one is have to check itself. Okay, reflexive property. L is perpendicularity exists when two lines are in 90 degree. Okay, two lines are taken in a 90 degree. The perpendicularity holds. Okay, here there is only one line. The reflexive property not holds. Now I will select for the symmetric property. Okay, symmetric means L is related to M. Again, M is also related to L. This one is the, I will take, consider as a L line. Here, this is M line. L is related to M. Again, I will take M is also perpendicular to L. Now, the symmetric property holds. Again, for checking the transitivity, L is related to M. It means L is perpendicular to M. Again, M is perpendicular to M. There is a line M which is perpendicular to N. Now, again, for the first line, but L and N are parallel lines, not perpendicular. So, the property not holds. Only symmetric property holds. Therefore, option number B is correct. Now, I will consider the question number 11. Let R be the relation in a set containing the 4 images or 4 elements. Okay. Now, the relation is given here. There are 4 elements. First, have to check their images. 1, 1 is there. 2, 2 is there. 3, 3 and 4, 4 are there. So, reflexive property holds. Okay. Here, reflexive property holds. Reflexive property holds. Again, for 1 is related to 2. 2 is now again related to 1. There is no elements, such elements are present. Therefore, symmetric property not holds. Again, for third one, property, transitivity. Okay, here 1 is related to 3. 1 is related to 3 and 3 is related to 2. Again, itself 1 is related to 2, which is present here. Therefore, the transitivity property holds. Okay, here reflexive and transitivity. Checking the options now. R is reflexive, yes, correct. And symmetric, no. Symmetric property not holds. R is reflexive and transitivity, yes, but not symmetric. The option number B is correct. Okay, remind me again, have to remember here for any multiple choice questions, first have to write the conditions on left side in the answer paper. First have to check, okay, in rough page. After that you will write in the answer paper, okay, then you will get the good marks. Now, question number 12. Let W denotes the words in an English dictionary. Here the W denotes the words in an English dictionary. Okay, here define the relation R given by X comma Y belongs to W cross W. Here the cross product W cross W means, here W cross W means every element of W is related with every element of W. Okay, here every element of this W is related with every element of this W. For example, in words in English alphabet, that is A, B, C, D, E, F, G, H, I, J, K up to Z. Here, for this one set A, B, C, D, E, F, G, H, I, J up to so on. A is related to A. Again, A is related to B. A is related to C. A is related to up to Z. Similarly, for B is related to A. Like this. Okay. Now, first one. X and Y are having at least one letter in a common. Yes, of course, all letters are common. Hence, there is a reflexive property holds because every element is related to itself. So, reflexive property holds. Again, for the second one, symmetric condition. For the A is related with B. Similarly, B is also related to A. A is related with B. Similarly, B is also related with A. The symmetric property is also holds. Again, I will check the transitivity. A is related with B. B is related with A. Again, itself A is related with A. The transitivity property is also holds. Check these properties in the options. Not reflexive, the option number A, not there. Reflexive, symmetric and not transitive. This one is options also wrong. Reflexive, symmetric and transitive. Both the properties are holds. The option number C is correct. Next, let the function related R to R means real number to real number. Mainly real number containing the all the, okay, here real number containing all the numbers. Okay, this is the supreme of all numbers. It may be rational, irrational, real number, it may be rational, irrational, whole number, integers, even natural numbers also. Okay. Here, defined by f of x is 1 by x. X is belongs to R. Then f is 1, 1 and on 2. Okay. Here, real number to real number, the question itself is a bijective. Because for every element of, we have taken x. For example, f of 1. I will take x is equals to 1. Then what is the answer? 1 divided by 1. The answer is 1. 1 is also number. 1 is related to 1. This is also real number. This is also real number. Then it is related to real number. Then 1 1 function. Again, if I will consider as a, from this one, taking as a 1, the answer is again 1 is related to 1 only. Therefore, the function is bijective 1 1 and onto. Let f is real number to real number is defined by. Here the function is real number to real number is defined by f of x is equals to 2x plus 6, which is bisective mapping. Bisective means it has both 1 1 and onto condition. It holds both 1 1 and onto condition. After that, we have to finding the f inverse. First, have to take f of x is equals to 2x plus 6 here. F of x is equals to 2x plus 6. Make f of x as a y. Okay. That is 2x plus 6. Again, solve for x. Then taking 2x on right side, my plus 6 taking on left side, it becomes minus y minus 6. Y minus 6 is equals to 2x. We want only x, so x is equals to taking 2 on this side, it becomes y minus 6 divided by 2. Check this answer in option. No, this answer is not there in option. So have to take separately. It is y divided by 2 minus 6 divided by 2. So 2 ones are 2 threes are. The answer becomes y by 2 minus cancellation, it becomes 3. So y divided by 2 minus 3. Check in the options. All values are in terms of x. So take this one y in terms of x. Replace y by x. You will get x by 2 minus 3. Check in option box. The option number 1 is correct. This is the f inverse of x. Okay. If they ask for inverse, have to take the function, then make it f of x as a y. After that, solve for question
X.
number 15.
Okay.
If the set A contains 5 elements and set B contains 6 elements, then the number of 1 1 and onto mappings from A to B is. Okay. Here there are two sets are there. Okay. Here there are two sets are there. Set A and set B. Set A containing 5 elements. Set A containing 5 elements. 1, 2, 3, 4, 5. I will take the elements for my reference. Okay. And set B containing 6 elements. 1, 2, 3, 4, 5, 6. Okay. For 1 1 condition, 1 1 mapping, there are 5 elements. One is related to 1. Okay. So every element is related to itself. The 1 1 condition obeys. 1 1 condition obeys. But for set B containing, there are 6 elements. Here only 5 elements are there in set A. Therefore, the onto function not holds. If 1 1 and onto mappings both holds, then we have to find the number of elements. Otherwise, the range does not exist. The option number 0. Therefore, 1 1 and onto mappings are not present. If 1 1 and onto 1 1 condition obeys, but onto condition not obeys. That's why there is no number of 1 1 and onto mappings from A to B. Next question, question number 16. Let A is equals to 1, 2, 3 up to so on for n elements and set B containing 2 elements A and B. The number of surjection from A into B. Here, first, even we have to study the 1 1 and onto conditions. Okay. 1 1 and onto conditions in functions. Okay, here for one condition we have another one word is there, that is injective function. That is injective function. For unto condition we have to say that, that is surjection or surjective function. Okay, here the number of surjections from A to A into B, from A into B. There is a one formula for finding the number of surjection from A into B is 2 to the power n minus 2. Here n means the number of elements present in the set B. Okay. Here then for the surjection the number of n is number of elements present in set B. That is 2 to the power n minus 2. You have to substitute values in this condition, you will get the answer. Okay. Here there are two elements are there in set B. 2 to the power 2 minus 2. That is 2 to the power 2 minus 2. 2 to the power 2 means 4 minus 2. Therefore 4 minus 2 means 2. There are only two relations because these two elements only mapping with and other elements. Okay. The number of surjections from A into B is 2. Here they given the equations. They given equation. Similarly, for one condition or for injective function, the relation is, that is for finding the number of relation is n factorial divided by n minus m factorial. Here there is a formula for finding the number of surjections from A to B is 2n to the power 2. Again for injective, that is n factorial divided by n minus m factorial. Now question number 17. The function f from R to R be given by f of x is equals to 3 minus x cube to the power 1 by 3. Then f of x is, okay, f of x is, it means f of x can be written as f of o means of, it is bracket f of x. First take the function f. What is the f of x? What is the f of x? Values replace here, that is 3 minus x cube to the power 1 by 3. This is the f of x. This is the f of x. We want f of x. Here, it means whole value taken as a x. F of x means here the function. What is the f of x? For this function, we have wherever x, we have to take this value. Here, 3 minus, what is the value of x? In place of x, we have to taking this equation, that is bracket of 3 minus x cube to the power 1 by 3 whole to the power, okay, 3 minus x cube whole to the power 1 by 3. Okay. Now, simplify this one. This 1 by 3 and 3 get cancelled. Here this one is 3 minus. For bracket, I have to taking the bracket 3 minus 3. 3 into 3, it becomes plus. Okay. X cube whole to the power 1 by 3. This one get cancelled and 3 minus get cancelled. Again, we have the value x. Again, we left the value x here. The answer is, what is this? None of these. Here there is answer not present. Okay, here this is, the answer is x, which is present. The question number 17 is f of x is again x itself. Now, question number 18. Question number 18. Don't worry about this because this one function is not for your annual examination, but this question will be asked for in seat. Let question number 18. Let a function f from R tends to R be defined by f of x is equals to 3x minus 4 is invertible. Invertible means it holds both 1 and onto condition. It holds 1 and onto condition. After that, there is a both conditions satisfied. Then the function is says as a invertible. Okay, we have to find the f inverse of x. Again, have to take the f of x is equals to 3x minus 4, taking f of x as a y is equals to 3x minus 4. Again, solve for x. We want x value, taking minus 4 on left side, it becomes plus y divided by 4 is equals to 3x. Again, we want to x value, it becomes y plus 4 divided by 3. Okay, this is the answer. Check in option. There is no options similar to this one. Now, here replace in the answer only. Replace in the answer. Replace y by x. That is x plus 4 divided by 3. Now, check the option. The option number A is pressed. So, the answer is x plus 4 divided by 3. Option number A is correct. Here, find the number of all 1 function from set A 1, 2, 3 to itself. Here, we have to find the 1 function from itself. Here, in question number 16, A to B. Okay. Here, there is a set A is containing different number of elements and set B containing different number of elements. But in question number 19, itself, the word says itself means the number of 1 function is, and that is 2n. The rules is the number of 1 function for itself. Number of 1 function itself is 2n. N means number of elements present in set A. How many numbers are present in A? There are 3 elements. So have to multiply 3 into 2. That is 6. The answer is option number C. The option number C. The answer is 6. Now, let's move on the question number 20. Let f of x is equals to x. Then find the f of x. Okay. Here, first have to take the f of x. Okay. Here, f of x is 1 by f of x is x. We want f of x. First, I can return f of, what is the f of x is? X. Again, what is the f of x? That is x. Okay, that is x. The x option not present in the, here there is no options like this. So, this is exceptional cases. Exceptional cases. There is a grace marks for the, like this question only. Okay. Now, question number 21. When you solve, then you will get answer in the, means one condition is if you have failure for solving a problem, otherwise sometimes options may be wrong. Let here question number 21. Let S is equals to, set containing S is equals to A, B, C and T is equals to 1, 2, 3. Then which of the following function from S to T F exists? F exists means there are two sets S and T. Okay, here there is mapping A, B, C. 1, 2, 3. Each element is related to one element only. Here while checking this, A is related to 3S, B is related to 2S, C is related to 1. So the option number A is correct. Otherwise, I will check for these options also. Here, S and T. A, B, C. 1, 2, 3. A is related to 1. A is related to 1. B is again related to 1. C is also. This is not possible. If the function exists, must and should the one element related to a unique element only. The function does not obey this condition. Similarly for this one, A is related to B. B is related to 1. Again C is also related. So there are two elements are related to one element not present. This option is also not. A is related to 2. B is also related to 2. This is also not possible. Okay, the option number 1 is correct. If a relation R on the set 1, 2, 3 is defined by only 1, 1 is present. Here only one is present. There are three elements are there. By the condition of reflexivity, there are three elements, so their image is also present. That is 1 and 2 3 3. Here only the elements of 1 present, so reflexive condition not satisfied. Again for symmetric condition. For symmetric condition, 1 is present. Okay. Here 1 is related to 1. Again 1 is related to 1 only, because there 1 is related to 1. Again 1 is related to 1. The similar pair of elements are not written in 2 times. We already know the set. Okay. Conditions of set. There are the repeated elements are written only once in the flower bracket. By that property, we have to say the condition is symmetric property is holds. Similar that manner also conditionally, some condition based on some condition, the transitivity is also holds for this one. The transitivity also holds this. Therefore, the option number C is present, because symmetric but not transitive. No, transitivity also holds. Transitive but not symmetric. No. Symmetric property also holds. Neither symmetric, no. No. Both are present. Therefore, the option number C is present. Up to this much, I cover some questions on as well as concept. Okay. Have to practice these questions and also practice similar questions. You will get the good marks in the annual examination as well as for CET also. Okay. Thank you. Hope for good and read well. Thank you for watching my channel. If you are very interested about my concept, and then please share, subscribe, and after watching this video, please press like button as well as subscribe my channel. Thank you.